Hello, welcome back student to design and analysis of algorithm subject. Today we are going to see the another topic from the unit 3. Before going to the today's topic, we will see what we have done in the previous lecture. The previous lecture we saw dynamic programming method. What is dynamic programming method? The dynamic programming method, we can take the decision in every stage. It is not a predefined. Okay, so we saw how many methods. In this method, how many problem can be solved. So in the previous lecture I told you, and from there I pick up the 0 by 1 knapsack problem from that and we solve that. Okay, and today's topic is the dynamic programming method. Again, we need to use the same method to solving the multi-stage graph. Okay, in the multi-stage graph there will be a graph with different stages. In every stage it will going to take the decision. It is not like a greedy method is predefined, means it is before starting is decided to go from here. It greedy method will follow the constraint to complete the task, but in the multi-stage graph, in every stage it will take the decision. Okay, so let's see what is multi-stage graph. The multi-stage graph, we have a graph. Okay, then g of v comma e. Okay, as you know, so here the multi-stage graph, e of v and e. What is v? V is vertices, e is edges. Is a directed graph in which vertices are partitioned into k greater than or equal to 2. Is joint set vi of I, where I less than or equal to k. Okay, I should be greater than 1 and k should be greater than 1 as well as I. Okay, so this is a condition. In addition, if uv is an edge e, then u belongs to vi, u belongs to vi, and v belongs to vi plus 1. Okay, so this is a formula. Okay, let's see I comma j. Let's see I comma j be the code of the edge, that is ij. We are making the we are solving the I comma j. The cost of the path from S to T means in every graph we will have the S and T, starting point and the terminal point, and in the middle we will have the different nodes or edges. Okay, like this. Sorry. Like this we will have a edges. So in this, S and T will be the starting and termination. Need to go from starting point to termination point. The sum of the cost of the edge on the path. So here, as dynamic programming, to also find the optimal solution. Optimal solution will be a different ways. Like if I want to go from S to T, I can go like this. Okay, I can go like this, I can go like this, I can go like this. Okay, example. So there will be so many ways, but we need to find the best solution, optimal solution from S to T. Okay, optimal may be a minimum or maximum. Because of that, it is written as optimal. Okay, so let's see the formula. The multi-stage graph problem is to find the minimum cost path from S to T, the value on edges are called cost of edge. Cost of edge. So here we need to find cost. This is a formula, and this is very important formula to solve the minimum, sorry, find the optimal solution for the multi-stage graph. Cost I comma j is equals to minimum T of jm plus cost I plus 1 comma m. So this you will going to be understand when we solve the problem. Okay, so that is cost I comma j equals to cost level level and number of nodes at that edge. How many number of nodes on that edge? So C is a weighted assigned on each edge. C assign the weight on each edge. K is a number of stages. How many stages are there? That also we need to see. How many vertices are there? We need to see, and which edge weight is best. We need to that also, that is C. Okay, and here is a problem. Is a problem, and here phi. Okay, and here you can see in this graph, multi-stage graph, we have a S and T, our source and termination, means starting point here, okay, and ending point is here. So here we have how many stages? As we define K as a stage, okay, this K as a stage, so how many stages are there? 1, 2, 3, 4, 5. How many stages we have? 5 stages we have. On every stage, it will take the decision which one is the optimal solution, and this is called forward solving method, means in the forward direction. Okay, the forward direction. How we will see that? Okay, so this is the example, and this example we need to solve with this formula, and we will get the values. Okay, like you can see every stage has a weight: 5, 3, 6, 5, 8, 6, 2, 6, 4, 1, 2, 3, 7. Okay, every edge has a weight. That weight is represented as C. Okay, so let's see the formula. Based on the formula we will solve this. So we will go back to the problem here, the third unit. Okay, and this all notes are available on my blog for all learners.blogspot.com. You can go and can see the, you can download the PDF of this notes. So this is a graph what we have seen just now. So based on this graph we need to solve, and we need to take the decision which route the best route. Okay, we need to take the decision which route from 1 to 9, from 1 to 9, which route is the best for the optimal. Okay, for the optimal. So here the solution in the step 1, in the step 1, according to the formula, we need to find cost I comma j, cost I comma j. So as we said in the here, that should be greater than 2, k greater than or equal to 2. So what we need to do, how many stages we have? The stages, 5 stages we have. So what we are doing here, 3 nodes are selected as j because at stage k minus 2, how many stages? 5 minus 2 equals to 3. Okay, 5 minus 2 is equals to 3 stages. There are 3 nodes, that 4 5 6 in the graph. Third stage, which one? 1 2 3, this is a third stage. In the third stage have 4 5 6, 3 vertices are there, 4 5 6, so that we have the value of I is equals to 3 and for j is equals to 4 5 6, 4 5 6. Why I is equals to 3? I is equals to 3, the vertices. Okay, and here we have 3 option here to choose minimum cost as k is equals to 3. What is k? K is a stage. Okay, so here cost I is equals to 3. Here what is? I is equals to 3 and k is equals to 3. And what is j? J is 4 5 6. So you need to take first j is equals to 4. Then afterwards we will take the 5. Then afterwards we will take 6. So 3 comma 4 ij. And what is the formula? Formula is cost I comma j equals to minimum of P of j. Minimum of P of j. What is our j? J is 4. 4. Then m. What is the next stage in the graph? Next stage is from the 4. What is the next stage? From the next stage is 7. First it is going to the 7 and from 4 it is going to 8. So first we will take the 7. So what we have taken here? 7. Okay, this is, what is this? I, and here m. What is this? Sorry, this is j. This is I, j. And here cost, okay, j comma m, we got it. Next, cost 7 comma 9 means j comma, what is in the formula? Cost I plus 1 comma m. So what is I comma 1? Okay, so here cost, you need to check the next. What is the 7 comma 9? What is 7 comma 9? Okay, here 7 comma 9, what is the weight? Is 7. So 7 is this, 7 comma 9. What is the value of 7 comma 9? Is 7 here. So here 7 comma 9, because we are here, when we move from here to here, then we need to go to the termination point also. Okay, so here we need to take this also. So here 7 comma 9, or here we completed the 1, 4 to 7, 7 to 9. Now we have the next another possibilities from 4 to 8, 8 to 9. Okay, 4 to 8, 4 to 8. Okay, 4 to 8. This 4 is not this one. The 4 is the stage. 4 is a stage, and 8 is a vertice. Okay, 4 is a stage, 8 is a vertice. Okay, plus cost of 8 to 9. What is the cost of 8 to 9? That also we need. So cost 8 to 9. So as per the table, 4 comma 7, 4 comma 7, from 4 to 7, what is the cost? Is 1. Okay, and cost from 7 to 9, from 7 to 9, the cost is 7. Or 4 comma 8, 4 comma 8 is weight is 4, and cost 8 comma 9 is 3. 4 plus 3, this is 8 and 7. Now we need to find which one is a minimum. 7 is a okay, 7 is a. So how we are getting that 7? While taking the 8th vertex. Okay, when we have taken the 8th vertex, this 8th vertex, we got the answer 7. Okay, in the simple way we can make a table so that will be easy for you to remember all the points. Okay, next, what we have completed just now, we completed the third stage. Okay, in the third stage, 4th vertex. Now we need to do the third stage, 5th vertex. Minimum of 5th vertex, j, ij, 5th, comma 7, 5 comma 7. How many places it is going? From 5 to 7 it's going, and from 5 to 8. The edge is connected between these two. So first we will take 5 to 7. 5 comma 7 plus cost of 7 comma 9, from 7 to 9, what is the cost? That also we needed. Okay, so here, since remember 7 comma 9, 7 comma 9, our cost is 7, and 8 comma 9 cost is 3. 3 and 7, remember this. Okay, 7 comma 9, what we have? 7 comma 9 is 7, or 5 comma 8. Why we is taking the 5 comma 8? Because 5 comma 8, this one, because two outgoings are there to the 5 comma 8, then plus 8 comma 9. What the 8 comma 9? We have already 3. Okay, 3, and this is 7. So here check 5 comma 7. What is 5 comma 7? 5 comma 7 is 6. So here we got the 6 plus what is 7 comma 9? 7 comma 9 is 7, or 2 5 comma 8. What is 5 comma 8? 5 comma 8 is 2. Got the 2, and 8 comma 9. What is our 8 comma 9? Is 3. So when we make a total, 13 and 15, 13 and 5, which one is a minimum? 5 is a minimum. 5 is a minimum. And how we got it? With the help of 8th vertex. Okay, the help of 8th vertex. Come down. Next, we completed 4 and 5. Now the remaining is 6 in the stage 3. So 3 comma 6, 3 comma 6 plus minimum of what is j 6 comma 7. From the 6, how many outgoings are there? From 6 to 7 and 6 to 8. From 6 to 7, we have some value, 6 to 7. The next is cost of 7 to 9. Cost of 7 to 9. What is 7 to 9? The cost is, already I have 7. 6 comma 8. C 6 comma 8. From the 6, it's going to 8. So what is the cost? 2. Cost 8 comma 9. Already I have 8 comma 9 is 3. Okay, and what is 6 comma 7? What is 6 comma 7 is 6. So here 6 plus 7 or 2 plus 3, 13 and 5. Which one is the minimum? 5. And how we are getting this? When we take the vertices 8. When we have the vertices 8 in the 4th stage, that because of that we are getting the so here in the step 1, we can select the node 8 because it gives us the minimum path from k minus 2 to k. From here k minus 2 till the termination, we got the minimum path. Which one is the minimum path? 8. We are getting the, with the help of 8, we are getting the minimum. Okay. Now next one. Next one is step 2. Now just now we finished the k minus 2. Now we will do the k minus 3. K minus 3. So what is our k? Is 5 minus 3 is equals to 2. And how many in the stage 2? How many vertices are there? In the stage 2, we have the 2 vertices, 2 and 3. How many vertices? 2 and 3. So we have the value of I is equals to 2 and for j is equals to 2 and 3. We have 3 options here to choose minimum cost at stage k2. We need to find the minimum. Okay, k is equals to 2. So here, what is this 2 2? First one is a stage, 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 or with the help of formula we can say this is I. Okay, what is 2? 2 is a vertices, this stage and vertices. Okay, or in the formula we used to say is j equals to minimum c of j. J means vertices 2. From 2, how many, where it is going? 2 to 4 and 2 to 6. So 2 to 2 comma 4, what is the way 2 comma 4 is 3 plus cost 4 comma 8. 4 comma 8. What is 4 comma 8 cost? 4 comma 8 cost is 4. Already we got it. Cost 4 comma 8 equals to 4 comma 8, we have 4. Why we are not going to the 7? Because in the previous step we got the minimum with the help of 8. Because of that only we are taking this 4 comma 8, the value is 4, and the same cost 8 comma 9 equals to the previous one. 8 comma 9, the previous is 3. Okay, so here we got it. And next, minimum this week completed. What cost 4 comma 8? 4, cost 8 comma 9 is 3, or 2 comma 6, because from 2 it's going to 4, from the 2 it is going to 6. Okay, C 2 comma 6, C 2 comma 6, what is the cost? C 2 comma 6, the cost is 3 plus cos 6 comma 8. From 6 comma 8 we are not taking 7 because we have selected the 8. We are getting the minimum cost with the help of 8th vertex. 6 comma 8, the answer is 2. And cost 8 comma 9, cost 8 comma 9, what is 8 comma 9? Already we have here is 3. So now see 3, 4, 3, or 3 plus 2 plus 3. Minimum 10 or 8. Which one is the minimum? 8. And how you are getting this 8? With the help of what it says 6. Because of what it says 6, we are getting the answer 8. Okay, so here the answer we got total is 8 with the help of what it says. So remember this 6. Here we got the 6. In the top we got the 8th vertex. Now check the next one. Next one in the second stage, third one. What it says is, what it says is third one. Second stage, and 3 is a what is it? Okay, with the help of formula you can say I comma k. Minimum T of 3 comma 4. 3 comma 4. What is 3? 3 is a what it says, from the 3 it's going to 4, from 3 it's going to 5, from 3 it's going to 6. So from 3 going to 4 the total cost is 6. So here first 3 comma 4, okay, then afterwards cost of 4 comma 8. Once it is going from 3 to 4, so we need to go from 4 to 8 because 8 is selected as a minimum. Okay, so what is the value of cost? 4 comma 8. 4 comma 8 already we have 4, and cost 8 comma 9 already we have here is 3. Or next, from 3 to 5, what is the cost there? 5 plus cost 5 comma 8. 5 comma 8, here also we are taking 8 because we have selected the 8. Remember that 8. What is 5 comma 8? 5 comma 8, the formula is, we got the answer is 2. What is the weight of 5 comma 8? Is 2. Cost of 8 comma 9 is 3. Okay, here 3, here 4. Next We completed this 4 and 5. Now the remaining is sixth one. The sixth one, T3, 6, third stage and sixth vertices. Okay. Plus, what is the value of 3, 6? 3, 6, the value is 8. And cost 6, 8. Cost 6, 8. What is the cost of 6, 8? Is 2. And cost 8, 9. 8, 9. What is 8, 9? Is already we have here 3. Okay. And what is 3, 4? 3, 4 is 6. So when we add this 6 plus 4 plus 3, 6 plus 4 plus 3, and or 5 plus 2 plus 3, 5 plus 2 plus 3, same, 8 plus 2 plus 3, 8 plus 2 plus 3. So when we add all this cost is 13, 10, 13. So which one is a minimum? We need to select that. So we selected the 10. And how we are getting this 10? With the help of vertices 5. Okay. How we are getting the 10? With the vertices 5. So here from the both cost of 2, 2, cost of 2, 3. Okay. What is this? 2, 2, second stage, second stage, and what is 2? Second stage, third vertex. Okay, state and vertex. So in this, what is 2, 2? We got it. We got it 8. Sorry, yes, 8. And how we got it? With the help of sixth vertex. And here cos 2, 3. What is the answer? 10. And how we got it? With the help of vertices 5. So which one is a minimum? This one is a minimum. Select this 6th as a node. Node 6 is selected as a minimum cost. Okay, till we reaching the termination. So this is, we completed the k minus 3. Now we will do the k minus 4. Okay, k minus 4. Only one node is selected as j because at the stage k minus 4 only one. There are only one node, that is 1, and we have the value of I is equals to 1 and for j is equals to 1. We have 3 options here to choose minimum cost at the stage k is equals to 1. Okay, here from the stage 1 it's going to 2 and 3. That's 1, 1. What is 1, 1? 1 is a stage, first stage, and this one as a vertices is equals to minimum C of 1, 2. What is 1? 1 is vertices. From it's going from 1 to 2. Another vertices from 2 plus cost 2, 6 from 2, 6 when it is going from 2, 6. Okay, what is 2, 6? You can go like this, or you can say 2, 6 is nothing but stage. Okay, so 2, 6 we got it 3, and what is 1, 2 is 5, and cost 6 comma 8, from 6 to 8, what is the cost? 2. Again, from 8 to 9, what is 8 to 9 is 3. Or C of 1 comma 3, stage 1, and it is going to 2. 1 comma 3, vertices 1 going to 3, plus cost 3 comma 6, from 3 is going to 6, because we selected the 6th node in the previous step in k minus 3. Okay, so here 2 and this one is 8, and from 6 to 8, from 6 to 8 is 2. 6 to 8, the vertices edge weight is 2, and from 8 to 9, from 8 to 9 is 3. So 5 plus 3 plus 2 plus is equals to 5, 3, 3 plus is 13. The next is 2 plus 8 plus 2 plus 3. Total is 15. So here we are getting the answer 1 comma 1 is 13. What we are getting the answer? Minimum is 13. And how you are getting the 13? This, when you selected the vertices. This vertices. So node 2 is a selected as it has minimum cost. Okay. So from the 1 to 9, which stage if I go, that will be the best and optimal solution. So what is this? 1 to 2, whatever the node you selected, yes, you need to write here. Node 2 selected, then after that, what did you select in the previous one? Node 6 you selected. So write the node 6. Then after that, what did you select? Node 6. Then here in the step 1, we have selected the node 8. What we selected? Node 8. Then last one is, so this is our decision how it will go by the problem from S to T. 1, 2, 6, 8, 9, the optimal solution we will get here. Okay, and what is the total cost? That will be 13. 13 is the total cost 13. You can reach the destination. Okay, once again I will repeat this from the starting. Okay, here in this graph we have k 5, k is equals to 5, k is equals to 4, k is equals to 3, k is equals to 2, k is equals to 1. This is the stages. Okay, here k, you maybe got confused, why did you select starting from k minus 2? Don't worry, I will show you. K minus 1, k minus 1. Okay, if you do k minus 1, so what is the value? 4. What is this 4? This is a fourth stage. In the fourth stage, what is the vertices we have? We have the 7 and 8. From 7 to 9, how it is going from 7 to 9, okay, and here 8 to 9. Directly, because it is a 1 only, so we no need to do any minimum formula here, as we have the min. But when we have only one, what if one outgoing edge from the vertices, so no need to do minimum. Directly you need to write whatever the weight. Okay, 7 comma 9, 8 comma 9, we got the answer 7 and 3, because there is no computation, only one output from their vertices. Okay, so after that k minus 1, then afterward we did the k minus 2. In the k minus 2 we use these values. Can you see 7 comma 9, we use the cost of 7 comma 9, and here we use the 8 comma 9, the 8 comma 9. Okay, so like this 4 comma 7, 4 is a fourth stage, okay, and 7 is a vertices, okay, vertex. So here 4 comma 7, what is a 4 comma 7? 4 comma 7 value is 1. So here we got the answer 1, and cost of 7 comma 9, 7 comma 9 the cost is 7, or 4 comma 8, 4 comma 8 as per the table, as per this 4 comma 8 is 4 plus 3, is 3. So when we calculate this, here the two things are there. So here you need to find the minimum. Okay, here you need to find the minimum. Which one is a okay? Because here 1, 2, the two nodes are there, outputs are there. Here it was a 1, so directly we got the answer. Here we need to do the minimum. From both we need to got the minimum. How did you get? With the help of vertex 8. The same thing here 3 comma 5. What is this 3 comma 5? The stage 3 vertices vertex 5. Okay, k minus 2 is 3 stage. Third stage vertex 5. So C from 5 to 7 is one edge and 5 to 8 is one edge. And here this is a previous cost what we got it. So you need to add here. So from 5 to 7 we have a 6 as per this table. 5 to 7 the answer is 6, and 7 to 9 already we got it is 7, and 5 comma 8 from 5 to 8 is answer is 2 plus 3. 8 comma 9 is 3. So from both which one is a minimum? 5 is a and what vertex here 8. Okay, so here also you need to do the same operation. T of 6 comma 7 from the 6, 3 comma 6 means what is 3? 3 is a stage, 6 is a vertex. As per the formula you need to say I comma j. Okay, 6 comma 7 and cost 7 comma 9 already we have. The 6 comma 8 plus cost 8 comma. So here after solving we are getting the answer 5, and how we got the answer 5? With the help of what? So here you need to check, okay, 3 comma 6 minimum cost we are getting with the help of vertex 8. 3 comma 5 we are getting the answer 5 with the minimum, with the help of 8 vertex we are getting the 5. Same vertex 3 comma 4, here also we are getting this minimum cost with the help of stage, sorry, vertex 8. So vertex 8 is present in the tree, so we are selecting the node 8 is vertex 8. Okay, because it's give us the minimum path from k minus 2 to k. K minus 2 to k means from 4 to 8, 8 to 9, when you go it is a minimum cost. Next, and if you go from 5 to 8, 8 to 9, that is also a minimum, and 6 to 8, 8 to 9, this is also a minimum, compared to 7. Compared to this 7, this is a minimum one from this all vertices. Okay. Next, same thing, k minus 3, 2. Same thing we are applying here. Checking 2 comma 4, 4 comma 8, cost 8 comma 9. Then we are solving and we are getting the value. But here we are getting the value 8 with the help of vertex 6. Okay, with the help of vertex 6 we are getting the value 8. But here I am getting the minimum value from this 2 comma 3 with the help of fifth vertex. But you need to check, compare from 10 and 8, which one is a minimum? 8. And 8, how did you get? With the help of sixth vertex. Because of that, we selected the node 6. Node 6 or vertex 6, both are same. So here we selected the vertex 6. Okay. And the last one is k minus 4. Here we are adding all cost 8 comma 9, 6 comma 8, 2 comma 6, 1 comma 2. When we complete all this, then we got the result 13. So what is the root? 1, 2, 6, 8 and 9. This is a root. So in the graph we need to ink color changing blue. First 1 to 2, okay, and from 2 to 6, from 2 to 6, from 2 to 6, okay. Then what is the next? 6 to 8, 6 to 8, then from 8 to 9. So this is our optimal solution. Okay. We have a different routes to go from source to destination, but what is this? 1 to 2, 2 to 6, 6 to 8, 8 to 9. This is a optimal solution. This is your final answer, and this is our decision. We have taken the, okay. So the graph, when you take 1 to 2, 1 to 1 to 4, 1 to 5, this is another example. You can take the example and you can do the practice. Okay, to try this, okay, just I am making a small multi-stage graph. This is an example, and this is called directed graph. Directed graph. Okay, thank you very much. Today we completed the multi-stage graph, the dynamic programming method. We completed the multi-stage graph. The next class we will see the next topics. Okay, thank you very much. We'll see you in the next class.